like to talk to you a little bit about Chapter 6 this week. In particular, in Section 6.2, we're dealing with the binomial distribution, and it is a very important distribution. You're going to see it quite a bit this semester, so I want to make sure you're comfortable with it. You have a probability called P, and that represents the probability of success in an individual trial. So every time you have a trial, you either have a success or a failure. But the thing of interest would be what happens if you have multiple trials. So I've got a little diagram here that I wanted to show you where I have different values for P, 0.25, 0.5, and 0.75. So let's say this is the probability of a sports team being able to win an individual game. Well, what if they play 6 games? Wonder how many games they'd be able to win. Well, this poor team, they only win 25% of the time. So you notice out of 6 games, they probably will win 0-1, maybe 2 games, slight chance of 3, but very unlikely they're going to win 5 or 6 games. However, a really good team that can win 75% of the time, then we would expect them more likely to have 4, 5, or 6 victories. Very unlikely that they'd have 0 or 1. So this is the thing we are able to calculate using binomial distribution. To calculate the probability of any number of successes in a set number of trials, you do want to use your calculator. However, if you want to do the mean or standard deviation, while it is produced by your calculator, if that's all you're after, you can just go ahead and say that the mean is n times p, number of trials, times probability of success. So, for example, this team that wins about half the time, you would expect them to win 0.5 times 6, or 3 games. Notice that is the most likely outcome. Okay? The standard deviation is a little more complicated, but still, you only need n and p to calculate. So I hope that makes this section a little bit easier, and good luck.